Hello and welcome everyone. I'm Joey D'Antoni, and this is SQL Server DR in Microsoft Azure. We're going to talk about building your second data center, and I spelled it the proper way for the rest of the world and not America. A little bit about myself. I'm a SQL Server MVP. I'm an MCSE for Business Intelligence and Data Platform. I'm principal consultant at Denny Cherry & Associates. And I'm co-author of a white paper that I wrote with Stacia Meisner entitled Using Power BI in a Hybrid Environment. We wrote that last year covering a lot of different hybrid scenarios. I'm on Twitter at jdanton, and I blog at joeydantoni.com. The slides, I think, are going to be up on the Rally site, but I also have the slides for this presentation on bit.ly/hybriddr, and I think I have some other links there as well. That link is case sensitive. So today's presentation, we're going to while I am a SQL Server MVP, I don't work for Microsoft, and I know there have been a lot of presentations here about hybrid, and it looks really easy because they just show clicks, and it's all Enterprise Edition and very expensive. We're going to walk through all the options available for DR and SQL Server and kind of see how those are implemented in a hybrid manner. We're also going to talk a little bit more than I usually talk about in a database session about networking, because networking is really the key to making a lot of this work. And when Microsoft showcases this stuff, they don't zoom in on the hard work you have to do to make it work initially. They just show it working. And we'll also just kind of generally talk about DR. If anybody has any questions at any time, please just stop me, because the way this is structured, I think it's better to ask a question when you have it. So disaster recovery. I've always worked a lot in disaster recovery. I think part of it is because I grew up in New Orleans, Louisiana in the US, and we always had hurricanes. And then everywhere I lived in the US until about 10 years ago was in a hurricane area. I lived in North Carolina for a while, and I supported manufacturing plants in the Caribbean. So I always had to worry about disaster recovery. I also had the good fortune of working in the pharmaceutical industry when I was learning about DR. And if any of you have ever worked in the financial or the pharmaceutical industry, you have to have policies and procedures for everything, to the point that it's overboard. But it was really good because we had good DR plans, and we were forced to revisit them and do testing. And we actually had a budget to do DR testing. I know that that's not a luxury that every business has. But really, every company and every application within a company should really have its own disaster recovery plan. How many of you work for firms that have DR plans? Okay, good. That's about a third of the room. That's better than average. I've seen one, and somebody's like, of course, your disaster recovery plan can be like this. But actually, it's funny. A perfectly valid DR plan is to fall back to a paper-based process if you have to, as long as it's understood by everyone in the company that in the event of failure, that's what you're going to do. The cool thing about Azure and the cloud computing in general is I feel like it democratizes a lot of this stuff. DR and real-time things used to only be available to very wealthy companies that had a lot of money, and now it can be done a lot more affordably. Little story about backups. The first time I was doing a presentation on hybrid disaster recovery was at the PASS Summit in 2013 in Charlotte, North Carolina. And this stuff was really new then, and it was really hard. So I was a little freaked out about my presentation because the demo was super fragile. But we were having, the night before I was presenting, we were having a get-together at a house someone had rented for the conference, and we were having some wine and grilling. And I like to cook, as you can tell. So I was asked to do the grilling outside, and I went outside and I lifted the propane tank, and it felt really light, and I couldn't get the grill to light, so I'm like, we're probably out of propane. Well, I look, and the grill was kind of like this, where there was an underdesk, and there was another tank of propane in it, so I pull it out. I'm like, I thought propane tanks were heavier than this, but okay. So I used my backup, and my backup didn't work. So the moral of the story is backups are great and everything, but you need to make sure you can restore them. Otherwise, they're pretty much useless. That's going to lead us into talking a little bit about doing some backup and recovery at Azure. But next we'll talk about defining disaster recovery. And some weird text got in. I just had to switch to 16:9, so ignore that text on the end of this. But the way we define our disaster recovery plans is to start with two things: recovery point objective and recovery time objective. And the two things are how much data can you afford to lose for your business, and how much time can you afford to be down. This is going to be driven by your business needs as well as the application's needs within your business. And really, any technology decisions you make in terms of how you're going to do disaster recovery should be based around those two things. After you make these decisions, you should write everything down, and this should really be made on a business system level, not a general company level. So you should, your ERP system is obviously going to be a lot more important than, say, I don't know, a file server. Those are the kind of decisions you should make. And the other thing I like to recommend is try to get as much executive sign-off as you can, because in the event of a big disaster, like what I'm going to tell you about in a second, you want to be able to restore the critical business systems and not have the CEO yelling at you because his Facebook page is down or something like that. My favorite DR story that I've always told, unfortunately this wasn't a true disaster, so nobody was harmed except for a large storage array. I was on call one weekend, and I got paged, and I was supporting Oracle as well as SQL Server at the time. And our Oracle servers were Linux servers, and we had a custom command prompt, and I got paged that a database was down. So I log in expecting to see a custom command prompt in the name of my database. And if any of you have worked with Linux, if you don't set up anything by default, you just get a number sign as your prompt, or pound sign. And I got that, and I'm like, that's kind of strange. And I tried to do a listing of files on the system, and I got nothing. Tried a couple other things, no success. So I called my boss, and I said, Alicia, this database is down really hard. I'm not sure what I can do. And she's like, oh, Joey, I was supposed to call you. The sand vendor, two-letter company beginning with H, came in, and they were decommissioning a SAN, and they took the wrong one. Yeah, so we actually had disaster recovery in place on some of these systems, but because we weren't doing regular failovers, we found corruption in a couple of our databases via the disaster recovery. Unlike SQL Server, Oracle doesn't do inline corruption fixing, and we found out our data was corrupt on the other side, so that was no good. But yeah, always. But having that process kept us in place, so we were able to get everything back. It just took about a week. So backing up your data really isn't enough. You should be regularly testing your recovery processes. And this is another thing where I find this is a really great use case for using something like Azure or Amazon EC2. You can back up data there, or even just copy a backup file there, spin up a VM, do a restore, and then spin it down, and you've probably spent $5 making sure you're €5 or however many kroner, doing a quick restore. I work for a cable company in the US, Comcast. I'm not sure if anybody's heard of them. They're pretty evil. Great company to work for because we had a lot of budget. But we had a 55 terabyte database that was doing 3 terabytes of transactions a day. And the application team was really upset because we couldn't give them real-time DR to another site because they were doing 3 terabytes of transactions a day. And we asked them when was the last time they tested a restore. And they were like, never. And so we were like, then you should really stop backing up your database because we don't think you can restore 55 terabytes in like 3 days. And they looked at us like we were crazy, and we're like, no, really, you should stop backing up your databases because you can recreate the data from other systems, but you really have to test restores, especially if you're on large databases. And then one last thing I don't have on the slide, but I think it ties into this backup and restore. You should be doing CheckDB, database consistency checks, at least as frequently as your backup retention period is. So if you're retaining your backups for 7 days, you should be doing consistency checks at least once every 7 days. I had a couple of clients in the end of last year that lost a lot of data because they went to restore a database backup and it was corrupt, or they found corruption and then they only had 5 days worth of backups or so, and they were doing CheckDB once every 7 days, and they hadn't found the corruption. So the 3 types of cloud computing, I'm sure you've heard this a lot. We're going to focus on one mainly in this session. We have software as a service, so things like Salesforce, Office 365, infrastructure as a service, Windows Azure VMs, Amazon AWS, Rackspace. I think that market's going to continue to consolidate. Google seems to be making a play for it, but I haven't seen much from them except more platform as a service offerings. I think infrastructure as a service is I also think, and this is just a little future speculating, I think you're going to see a lot of colos end up kind of fading away and moving more. Everything is going to go more into just a cloud-based model with Microsoft and Amazon, just because they have so much capital that they can invest in these projects, and the co-locations are going to have a hard time keeping up. And then finally, we have platform as a service, Microsoft Azure SQL database, and then Amazon has a similar offering called RDS. But today we're going to focus mainly on infrastructure as a service. Microsoft took a long time to get here. Their initial assessment of the cloud market was going to be that it was going to be a pure platform as a service offering, and they wouldn't need to do infrastructure as a service. I saw Mark Rusinovich, who's the chief technical officer of Azure, talk about this last year or 2 years ago at TechEd. I tend to agree with him. I just think they were a little ahead of the curve. And a lot of organizations still need the flexibility that infrastructure as a service requires. For example, in the Azure database, even though it's almost fully feature compatible with SQL Server, you still can't have things like domain authentication. There's some tricks you can do with Azure AD, but it's not the same as we'll talk through the networking piece, but when you have your network configured and you have a VPN connection to Azure infrastructure and you have domain connections, unless you have access to the Azure portal as a DBA or even an end user, you won't necessarily know that a machine's in Azure versus in your own on-prem data center. So it's really just an extension. So up till 2012, Amazon was the only way to go if you wanted a cloud VM. The original Microsoft offering was called Windows Azure, which I never fully understood, but it was a kind of a container that allowed a block of program code to run in the cloud. And we had SQL Azure at the same time, which was the initial offering, which was an extreme subset of SQL Server features. Since 2013, we have Azure Virtual Machines. It's infrastructure as a service. The VMs are available pre-configured, or you can supply your own images. One thing to note on the pre-configured VMs, if you run a pre-configured SQL Server VM, you're paying for the licensing in that VM as part of your monthly fee. If you want to use your own licensing, which you can do, so if you have a license that you want to move into the cloud, if you have 4 cores of SQL Server Enterprise Edition, what you would then do would be to roll out a Windows VM and install SQL Server on it. You can't take advantage of the pre-configured templates. One other thing I'll mention about the pre-configured templates, and this really annoys me, does everybody like the defaults that come when you click next, next, next in SQL Server? Those are really awesome, right? Like 1 tempDB file, cost threshold for parallelism of 5. Well, guess what? Microsoft went through and did a next, next, next install of SQL Server for you. So by default, when you build one of those templates, everything is configured poorly. I did a presentation at Past Summit last year. It's on Past TV about all the things you should change after you do an install of SQL, and I have some automation around it. So if you can look for that on the Past site or my blog. But yeah, so those VMs are next, next, next. So if you're going to do this on a large scale, I'd recommend supplying your own images, because that way you're a little more control of the licensing as well. You can also connect to on-premise AD or DNS. You can also use, for internet DNS, you can just use the Microsoft DNS, or you can specify your own on-prem DNS server. I mostly just rely on the Microsoft DNS. I've had better luck making that work for my demos. So Microsoft has data centers throughout the world. The 2 in Europe are in Northern Ireland and the Netherlands. And Mark Souza, who's the general manager for SQL Server, yesterday intimated that they were building a data center in a large country in Europe that really cared about its data privacy laws. And I'll probably take that a step further. I don't know what it is, so I'm guessing it's the country that makes really nice cars. Because I was having a discussion with someone yesterday before that, and I was like, I don't know why Microsoft doesn't have a data center in Germany. It doesn't make sense, but now they do, or allegedly. In the US, we're blessed. We have a number of them. The one other thing, and I'll mention this a couple more times, but I think it's a key thing to note. You need to protect yourself with high availability in DR, even if you're fully within the cloud. So you probably want to, if you can do it within regulation, you want to span data centers. This is it used to be pretty difficult to do. You kind of had to do it through the internet, but now it's available through Azure. We'll talk about that a little bit more with the networking, because Azure does have outages, as you've all seen. Mark had an outage in his demo, but most of the time they're limited to one data center at a time due to the nature of how they do changes. So why go to the cloud? We talked a lot about the logistics that are required for a good disaster recovery plan, and a lot of these aren't available to smaller companies. Things like having a redundant SAN or redundant data centers are extremely expensive. And a lot of those, when you have that in a DR scenario, a lot of those resources are sitting idle most of the time, so you're not even able to use them for secondary things like reading. When I worked for the large cable company, they had 3 major data centers and a couple of smaller satellite ones. That made DR pretty easy, but that company also makes like $60 billion a year, so a lot of the clients I work with don't have solutions like this. Or do they have the teams to manage a second site? So they may have enough personnel to have their own primary site on-prem and manage those servers, but they don't want to have to hire a whole different set of employees to just run a DR data center. So they'll have no real options if a disaster were to hit their primary data center. And I know that the cloud isn't the solution for every company or every system. Some systems may start running into performance issues the cloud can't handle. And we'll talk about this in the next couple of slides, because the next couple of slides are from when I did this presentation in 2013, and I like to talk about how things have rapidly changed. And then some people are worried about security. And it's funny, for companies that are scared of cloud security, and I come across this concern a lot, Microsoft has really good security at their data centers. The past board got to go on a tour recently, and they were telling me about some of the stuff, just some of the measures in place and the background checks that they do. The one client I had that was really concerned about it and would have been a perfect fit for the cloud was telling me, yeah, we're really concerned about security, and their servers were in a closet in their office. And I was like, okay. And they had one guy who was the DBA, the Exchange admin, the help desk guy, and the CTO, but they were concerned about security. So anyway, so this, I really like cars. I'm really into Formula One racing, so I'm a big Fernando Alonso fan. So I kind of put this slide together. Oops. Okay, so this was back in 2013. And this is a Toyota Yaris, which is probably a 1.2 liter car. And I used to say, if this was your workload, you're probably a good fit for using virtual machines. And then I said, if this was your workload, you probably wanted to be on physical hardware. That was in 2013. The biggest issue with Azure up until quite recently was I/O performance. The I/O performance was atrocious. I think you were guaranteed like 50 IOPS on a volume. So even to get to some reasonable level of IOPS, you had to span your data files across many data volumes. Well, starting with in late last year, we got these GSeries VMs. And we can scale up to 6.5 terabytes. I think it can actually scale a little bit more than that of solid state storage. And you can scale that up to about 50,000 IOPS, which 50,000 IOPS would, based on my experience and my consulting clients, would cover roughly 90% of the workloads that no, not even 90, 98% of the workloads that I've ever seen. So that's a big improvement. So Azure Premium Storage is also available. So you can get, if you're running very small Azure VMs, you can't get the premium storage. You have to have D or G series to get access to the solid state storage. And my understanding of the reasoning for that is Microsoft hasn't exactly published this, but it's related to how much bandwidth your VM gets, because they don't give you a guaranteed amount of bandwidth. But they feel like in order to deal with that performance storage, obviously if you're returning more data faster, you're going to need more storage bandwidth. And the D series and G series are the only two that have the bandwidth to deal with that. So now I like to say if your workload looks like this, and if you're into racing, this is a GP2 car, which is the second series to Formula One. If you're racing in Formula 1, you probably still need your own hardware, though. So security in the cloud, like I mentioned this earlier, Microsoft has worked really hard enhancing their own procedures to meet industry standards. The data centers meet all the requirements by Sarbanes-Oxley in the US. And additionally, Microsoft has ensured all their data centers are in compliance with the EU privacy mandate. Finally, you're connecting, if you're doing this properly, you're connecting over a VPN connection, and then all of your data is going to be encrypted through there. So that's also a secure way. I am going to talk a little bit about connecting not over VPN and some of the DR things you can do with that. I'm in the midst of recording a class for this company called Agility, and I've been going through all these different scenarios. If you have to, sneak preview of a few slides ahead, but if you have to do this without a VPN, I recommend using database mirroring. It's probably the most secure. I know it's deprecated. I tried, obviously you can't do anything that doesn't have a domain or that requires a domain. But I tried to do log shipping, and I had to open, I think, every port possible on my Windows server. But we'll talk through that in a bit. So the first thing I'm going to talk about is backup to Azure. So we have the ability to back up to Azure Blob Storage. This is a feature that was introduced in SQL Server 2012 SP1 CU2 or later. I've been told by Microsoft, I haven't tested this, if you're using a newer version of Management Studio, so if you're using that version of Management Studio, you can back up an older database to Azure. I just haven't tested it. The other thing, although this makes me question that statement, the other thing is it uses an external process. So there's actually an exe in SQL Server bin that's called backup to URL.exe. So this Azure backup's handled by an external process. You create a credential in SQL Server, and then you can just say backup to URL. It's really no different than backing up to your on-premises environment. Starting with SQL Server 2014 in Standard and Enterprise Edition, encryption is also available. And you don't have to have transparent data encryption configured to use this. You just configure straight up backup encryption. That was actually one of my favorite feature ads in SQL 2014 because I thought it was ridiculous that you had to buy Enterprise Edition to have encrypted backups in the past. There's also another feature that ties into this called Manage Backup to Azure. Has anyone heard of this feature? Okay, cool. Manage Backup to Azure is this feature that was introduced in SQL 2014. And when you configure it, all you do, you run a couple stored procedures. So you have to create a credential, and you have to create certificates for encryption. Actually, the certificates for encryption are optional, but you can encrypt. And then you just specify a retention period. So you tell SQL Server how long you want to keep your backups. It does your full backups and transaction log backups based on a rate of change in the data or a fixed interval. I have a blog post about it, and I think it was if more than a gig of transactional activity happens, it will take a transaction log backup. But really, all you do is specify the frequency or the retention period. You can specify this on the instance level, or you can specify it on the database level. There are some limitations, though. It's not perfect. Your databases have to be in full recovery mode. I talked to Microsoft about that, and they didn't really have a good answer as to why that was a requirement. I think they're really paranoid since they're handling the backups about anybody losing any data at all. So that was one of the reasons why they did that. System database backups are not supported, so you'd have to write your own script to do system database backups. Azure Blob Storage is your only option. You can't do a managed backup to AWS. And the max backup size is 1 terabyte. And I did some research into this. So the 1 terabyte thing is an Azure limit. That's a blob can't be any bigger than 1 terabyte. But I did some research to see if using the backup to URL feature, you could stripe backups across multiple files. Since it's using that external process, it won't allow you to do that. That's a limitation that they have right now. I think they're aware of it, and they're trying to work through it. Actually, and unfortunately, this feature goes over, it's going to be encrypted over the connection, but it goes over an endpoint connection to Azure. So if you have a private connection, it's not using this. I've been requesting to Microsoft that they enable support for some of the fancier networking that we'll talk about in a bit, but I haven't heard anything yet. So getting connected to Azure, this is the real requirement for most of these DR scenarios. Like I mentioned, in a couple of scenarios, you'll be able to go over the open internet, but I don't recommend it because you end up having to do weird things like open port 1433 to the internet, and I don't like doing that. Funny story about that, we were doing a demo for a client with it was the full BI stack, so it was like SharePoint, Power View, and all that. And we were doing it in Azure because Microsoft was funding the proof of concept. And they've since stopped this, but by default, earlier when you created the SQL server on Azure, they left 1433 open on a public IP. And they did, or maybe I enabled it, I forget, but that happened, and I was working with one colleague on it, and I was looking, something was running slow, and I looked in the log to see if anything was going on. And I had all these failed SA logins in the log, and I'm like, that's weird. So I called my colleague, and I was like, hey, Vince, have you been trying to log in as SA? We have a domain account set up. No. I'm like, okay, that's kind of interesting. Well, so I look up the IP addresses, and they're all like in Russia and China, just trying to hit my VM. So site-to-site VPN, this is the main way I recommend connecting if you're using a smaller installation of Azure, if you're going to have a handful of assets out there. This is probably the way to go. It requires either a VPN appliance, or you can use Windows Server 2012 routing and remote service access services to use. Basically, you're just using a Windows Server as a VPN connection. And then in Azure, you're going to have this concept of a virtual network. So all your assets are going to be within a virtual network. Once your assets are in a virtual network, they can talk to each other. You create a gateway for your virtual network. That gives you a public IP address. You connect your VPN appliance to that, and then boom, Azure is an extension of your data center. There's also something called point-to-site networking. So if you want to play with this in your home lab or a test lab, and you don't have a VPN appliance, point-to-site networking is a certificate-based networking, and I actually have it running on some VMs on here. It just downloads a VPN client, and you can get a connection that way. It's fine for testing, or even if you had to do admin work, but I don't recommend doing it for a production connection. ExpressRoute is what you want if you're doing a full-scale Azure implementation. And these prices are from October. I don't know. They may have gone down a little bit. This is a direct connection from either your ISP or a co-location provider to Azure. So the main ones in Europe are BT and Orange. Level 3 and Equinix have data centers throughout the world. So if you have assets in either of their data centers, they'll gladly offer you a direct connection to Azure. And interestingly, if I remember correctly, this was a lot cheaper than in the US. I think a lot of the pricing, they just changed the euro symbol and the dollar, but the networking, I remember specifically, was cheaper here, which I found interesting. So cross-region networking. This is something that's fairly new. I think we just got this at TechEd Europe last year. In the past, if we wanted to connect assets in one Azure region, or as Microsoft calls them, or data center, we had to we had to go back out from our virtual network through the public IP and connect them that way. Starting with this, we have this concept that's known as a local network. So you have one virtual network and one data center. So for my sake, I'm going to say US East, and then I have another one in North Europe. I give my local network in Europe the subnet of my US East network, and my US East network the subnet of my Azure one. And then I can connect those two networks. Then you can talk over the networks. There is, the way Azure is built, you pay for the compute, and you also pay for networking. So if you're doing any transfer that goes from one Azure data center to another data center, you do have to pay for that. I think you get a certain amount of bandwidth that you're paying for by default anyway, but anything over that you pay for. So that's something to think about if you're using VNet to VNet. Interestingly, there were no, up until around that last year, there were no static IP addresses in Azure. So every time you rebooted the VM, it got a new IP address, which made, I mean, you were controlling it within an IP scope, so you could scope your IPs. But as you can imagine, when I was doing my demos at Summit 2 years ago, and I had to reboot and stuff, that made that really exciting. Now you can this isn't available through any GUI. It may be in the new portal, but in the older portal, it's not available through the GUI. You can specify an IP address for your VM, only in a virtual network though. So if you have just a standalone VM that's not in a virtual network, you can't specify an IP. This is through PowerShell. And interestingly, you'll always come up with the same IP, but if you look in Windows at the network connection, it will show as a dynamic IP address. So it's really an IP reservation that's made for you at the VM level. The thing to remember about Azure, it's just a giant virtual machine farm. So it's very much like if you had your own VM farm. So SQL Server DR options. The first one I'm going to talk about is log shipping. Log shipping is one of my favorite DR options because it works on every version of SQL Server ever. It's really simple. If Microsoft ever said they were taking that out of the product, you could just write it yourself. So here we take transaction log backups on our primary server, and then we ship those backups to the secondary and apply them. Data can be read on the secondary except during transaction log apply. So depending on your scenario, you may want to only apply, if you're trying to use that for reporting, you may only want to apply transaction logs once a day. If you're using it for DR, you may want to apply every 5 minutes and not allow those databases to be open for reading. So setting this up in Azure, I just went through this. If you have a virtual network, it's just like on-premise. Those assets are exactly the same. If you don't have a virtual network, don't do this. Log shipping strangely involves a lot of ports. So the SQL servers have to be able to talk to each other. You have to write to the file system, so you have to open ports for the file system. You have to do something really bad. I didn't have a domain either. I was going all in for doing this in a bad fashion. So since I didn't have a domain, I couldn't grant access to each machine. So I had to use, for my SQL Server service accounts, I had to use the same username and password. It was just really messy. So I don't recommend doing this without a virtual network. The pros of this are it's standard edition. That's probably by far the biggest pro. It supports multiple targets, and we can read the secondaries. It's easy to implement within Azure. It is dependent on the backup on the primary. So this can, if the primary fails, you can start falling behind. The failover process is manual, so there's no automation like there would be in clustering or always on availability groups. And there's a reasonably high complexity. I don't think it's overly complex to set up. Most DBAs have worked with it in the past. And if you're using Azure in your model, it really does require networking and AD. But I hope you have AD. Anybody work on SQL Server that doesn't have Active Directory? Good, no one. Every now and then I'll get a client who's got some server that's not on AD, and everything just becomes entirely painful. So SQL Server replication. This is a really high-level view of transactional replication. I could do pretty much an entire presentation on replication, but so I'm not going to go into too much detail. But we have a publisher, we have articles on the publisher, and then a distribution database and a distributor agent. The one thing I'll mention with this is if you're in a really high throughput environment, you want the distributor to be on its own database. And then we have our subscriber. Interestingly, and here's kind of how this works in Azure, we just send the transactions over a public connection. Interestingly, this was, of all the methodologies I implemented without a network or a domain, this was the easiest one to set up because you only had to have port 1433 open. You didn't have to open anything else. So this will work pretty well without a network. It's even easier with a network. Let me step back a second. One thing I probably should have mentioned a little bit earlier, but when I'm talking about opening these ports, if you're working on an Azure VM, and specifically in the portal, there's this concept of an endpoint. And what an endpoint is a port that's a public port and a private port. So, for example, I talked about the thing where I left 1433 open for SQL Server. What I did for this was I mapped 1433 as my private port, and I just opened port 15,000. So in my connection string on my on-prem server, I used 15,000. Normally, I think that's a really crappy way of doing security, because it's pretty easy to figure out what port you're using. But in this case, I think it's going to protect you from a lot of just scripts that are going right after 1433. Once again, if you're using private networking in virtual networks, you don't really have to worry about any of these endpoints. It's really only within when you're connecting to VMs over the internet. Pros and cons of replication. We can replicate to multiple servers as well. We can replicate a subset of the data. So this is a really good solution for reporting. I could see this cloud model being a really... I was kind of thinking through some different scenarios when I was doing the training class I did on this. You could potentially... One of the things replication allows you to do is republish. So you can publish to a database in Azure and then republish that out potentially to other databases within Azure. I could see if you were a company that was globally distributed and you wanted to do reporting off that, it would be a nice way to do it. Transactional replication is in standard edition. This works pretty well in a hybrid model. It's really straightforward. The cons of the process are it's once again manual failover, so there's no way to do automation. And it's also a database at a time. We have an unknown recovery point objective, so it's really hard to tell how far you are behind. And with replication, unlike mirroring or availability groups where there are DMVs where we can check to see how far the data is behind, replication can be fragile. I like to say it works until it doesn't, and every time replication breaks, it's a really ugly failure, because basically you have to restore your entire database. That's been my I haven't had too many scenarios where there was a problem with replication and it didn't involve me restoring the original copy of the database. It does require a connection change for failover, so if you're using this as a DR mechanism. Replication's not truly a DR mechanism, but it can serve one as a pinch if you're just trying to protect your data. The other real advantage replication has for reporting over any other solution is you can change your indexing strategy on the secondary. So when we're going to talk about availability groups, Microsoft likes to mention the readable secondary feature, and that is good to know, but you can't optimize those readable secondaries for reporting. They have to have the same indexing that the first one has. So database mirroring. This is a feature that was introduced to SQL Server in 2005 Service Pack 1. It's somewhat similar to log shipping. It's just a little more automated and efficient. Database transactions take place, and they're compressed and sent to a secondary server. In this case, this would be without a witness server. There's two modes of database mirroring. There's high performance mode, which is asynchronous replication. That's only available in Enterprise Edition. There's also a high safety mode, which is synchronous. And in synchronous mode, the transaction isn't committed until it reaches the secondary, or the transaction log on the secondary. So it will impact performance on your primary system. So just be aware of that. In any hybrid model, you're probably going to be using asynchronous. So that pretty much limits this to Enterprise Edition. It's a really good model for a secured hybrid environment. I talked about log shipping and how unsecure it was. With database mirroring, you can use what's known as certificate-based mirroring, where you do authentication using database certificates. And that also encrypts your connection. So even if you were mirroring over the public internet, all that data is going to be encrypted. And once again, you'd only have to open one port for your mirroring endpoint. So that worked pretty well. One thing I will warn you, if you're doing that, the error messages are really cryptic. I had a weird certificate error message, and it took me a while to figure out what it was. Do you remember there's a generic mirroring error that basically says mirroring won't start, and you have to chase through a bunch of things to figure out what it is. Also, we have automated failover for this, and this involves a witness server. The interesting thing about the witness server, it kind of acts like quorum does in a cluster, where it arbitrates failure. The witness server can be running on any version of SQL Server. You can even run it on Express Edition. So the pros are we get automatic failover with the witness. Configuration is fast and easy. It's literally just a few clicks. Failover happens very quickly. My favorite feature about this, and this one's also going to apply to always-on availability groups, is that corrupted pages get fixed on from the secondary. So if the secondary detects that a corrupt page is coming across, it will attempt to repair it, and also repair it on the primary. The certificate model is really good for cross-domains and networks. It's probably the most secure way you can do a hybrid connection with no VPN, but you really want VPN. The cons on this, it's per database. So if you're using something like SharePoint that has 10 or 15 databases, and you want to provide DR using mirroring, you're going to have to write some sort of script so that they all fail over together. Asynchronous mode's only available in Enterprise Edition. And the most important one is this is marked as deprecated starting in SQL Server 2014. I think it'll probably make 2 more versions. If I had to guess, they're talking about options for disaster recovery in Standard Edition. I'm not sure what they're going to do, but I'd be willing to bet that it would involve Azure if I had to take a wild guess. You may have noticed Microsoft's kind of gone in this Azure direction a little bit. And our secondaries are inaccessible except for snapshots. So you can create a snapshot and do some reading at your secondary. One more quick licensing mention, because I know it's everybody's favorite topic. I'm not sure how many people are aware of this, but in the past, whenever you bought one license of SQL Server, you could always have a DR license for free. And starting last year, that changed. That only applies if you buy software assurance. So if you don't have software assurance on your SQL Server licenses, you have to pay for that second license. And also, if you're doing any reporting against your secondary, obviously that counts as use, and you have to license it. So I like to do a brief review of Windows Server clustering before we talk about availability groups, just because I know not everybody's always super familiar with it. So we're going to talk about a couple of things like quorum first. So quorum is arbitration between our cluster nodes. So basically, you want cluster to have a quorum because you don't want both nodes to think they're the only members up in a cluster, and both of them try to start a service at the same time. It generally won't happen in Windows clustering the way it works, but so here we have a few options. The first one being node majority mode, which if a majority of our nodes are down, the cluster goes down. That's bad because if you have a 2-node SQL Server cluster or an availability group, if one's down, your cluster service shuts down and everything is inaccessible. We have this other option, and there's really 2 options to this. There's node and disk majority, and node and file share majority. So in most of these hybrid scenarios, you're going to want to use node and file share, which I'll talk through in a second. So in this case, we have an extra disk, so our disk has a vote. Each of these objects have a vote for quorum clusters. So now our one node is down, but 2/3 of our cluster is up, so therefore it's a majority. And so our cluster stays up. The interesting thing about this is if you start thinking about, so in this case, this would look like a cluster, and our quorum disk would just be a SAN disk that both nodes would talk to. But if we start to think about using Windows Azure and a hybrid network, where do we want to put that? Do we want to put that file share in Azure, or do we want to put that file share on-prem? One thing you can do, and Windows Server 2012 gave us dynamic quorum, so you can adjust that. And Windows Server 10 truly solves the problem. Unfortunately, I don't think it's going to be out until next year. But Windows Server 10 has this optional cloud quorum witness, and it just creates a cloud object. It's an Azure Blob storage file, and that becomes your quorum. It's funny, I have a client who's not even using the cloud, but they really want that feature because they have 2 data centers and they don't have a third, and they just want to have the quorum disk be in the cloud. So always-on availability groups. So I like to lead with a little bit on Windows clustering because always-on availability groups require Windows clustering. It's not SQL Server clustering per se, but SQL Server makes calls to the Windows cluster service, which is how this works. So here we have instance 1 on node A and instance 2 on node B. And we have our availability group. Our availability group is a group of databases. Typically, you're going to want to have a logical association. Microsoft has tested availability groups with up to 10 databases in a group. If your databases aren't very high activity, you could go a lot more than that. So if you had, I always like to go back to SharePoint just because of the large number of databases it creates. So if you had more than that in SharePoint, and a lot of those databases in SharePoint don't do much, you could potentially do that, or you could create multiple databases, or multiple availability groups rather. Much like database mirroring, this is shipping compressed transaction logs across. And we connect to our availability group through what's known as a listener. A listener is an Active Directory virtual computer object. It has its own IP address as well. The cool thing about availability groups is we can use what's known as read-only routing to send traffic that's read traffic, and that's done through the client. And starting with the SQL 2012 client, there's a flag called application intent. An application intent read will send that traffic to the secondary. And we can span multiple locations, because even though we're using a cluster, availability groups don't have a requirement for shared storage, unlike a SQL Server failover cluster. Bless you. In this case, I'm going from Washington to Chicago. We can also go much further than this. Starting with SQL 2014, we can have up to 8 replicas. 2012 gave us 4 or 5 total. Now we can go up to 8. I'd hate to see the licensing bill for the person who has 8 replicas, but you can do it. So this does require a SQL Server Enterprise Edition. It requires a Windows cluster. A Windows cluster used to require the Enterprise Edition of Windows up until Windows Server 2012. However, Windows Server 2012 has the same feature set in both Data Center and Standard Edition. The only difference is the virtualization rights you get on the licensing, so you can just use Windows Standard Edition. My other recommendation, and this is just my recommendation as a DBA and it doesn't have a ton to do with availability groups, but always use the latest version of Windows for your SQL servers. And if your application vendor tells you you can't, tell them they're lying, because they probably are. I've never had an application complain about what version of Windows my SQL server was running on. Also, all your servers have to be in the same Windows domain. This isn't so much a limitation of availability groups as it's a limitation of clustering. Windows clustering only supports servers in the same domain, not even trusted. Our databases are going to fail over as a group together. Another question that comes up around this is, can I have other databases in an availability group, or on a database server that's in an availability group? And you can. So if you're using it for other things, you can have those databases there. There's no shared storage needed. We have both asynchronous and synchronous modes, and the same rules apply. You'll impact performance in the primary if you're in synchronous. We have automatic and manual failover, and just like mirroring only allows us automatic failover with a witness in synchronous mode, availability groups only allow automatic failover with synchronous mode. Up to 8 replica copies. If you use all 8, your Microsoft rep gets a new Bentley. Replicas can be read. And we can take backups in the secondary copies. I think this is a pretty neat solution if you're using Azure, because potentially, if you're using a hybrid model, you back up in the cloud to the cloud, and you back up on-prem to on-prem, so you always have backups local. So these benefits apply to both hybrid and really on-prem availability groups. You can read secondary copies of your data. So interestingly, you can offload your read workload to Azure. You can connect your reporting and BI apps or migrate apps. Seeing BI there made me think of one other thing. I talked a little bit about bandwidth usage, and there's really this big disconnect in Microsoft between Office 365 stuff and Azure stuff. Even though they might be in the server rack next to each other, they don't know each other is there. If you're using any Azure stuff and you're using Power BI, you will pay for the data to flow across. It does count as outbound data, even though it could be in the same data center. Don't ask, I don't work for them. There's one button hybrid configuration, and I'll talk about this on the next slide. It's not quite that simple. We can offload the backups, like I mentioned. I think that's a pretty good feature for offsite backup. Here we have the option to add an Azure Replica. This is new in SQL 2014. There are several dependencies. So you have to have already configured an always-on availability group in your on-premises environment. You have to have a Windows Azure subscription. That's obviously for any Azure thing. And then finally, you have to have either a site-to-site VPN or an ExpressWrite VPN. This won't work over a point-to-site, so if you're playing with this at home and you have the point-to-site connection, it won't work. There's no technical reason why it shouldn't work, but they put in a check for point-to-site networking, did not support it. I asked for them for some sort of override so I could demo it, and they said they'd try to do it, but they haven't done it yet. And that was a year ago. So I don't think it's going to happen. But so those two things are really the hard part, is having the subscription and having the network. So once and the availability group, because the availability group is going to require a cluster. And when you're going to go to create one of these hybrid clusters, you're going to have build it. It's a little weird. And this kind of goes back to the IP configurations. Now we can have 2 IPs on an Azure VM. Up until last year, you could only have 1. But even so, I don't think the recommendation on how to create a cluster has changed. You create a cluster, a single node cluster in your on-prem environment. You have to bring the cluster name online, where you can, and you do that when it's still a one-node environment. You assign the cluster name to a non-writable IP address, and then you take it offline. And then you can add your Azure Replica. I had to work through that in 2013 and help figure out that process. It was really ugly. There's really good documentation if you go to my blog URL in trying to do this, on how to do this. Microsoft just has some PowerShell scripts you run that create everything for you. And then it kind of looks like this. This is a little bit messy. Let's see if I have, I'm on my Mac. I'll point here. So here we have, this is our on-premise environment. So you want to have a domain controller. That's something else for any of these hybrid scenarios. You always want to have a domain controller in Azure, just because in the event that you lose your connection for whatever reason, you want to still be able to do domain authentication in your Azure environment. So here we have an on-premise domain controller. We have SQL on-prem. They can talk to each other over a couple of networks. And then we have our Azure gateway here, so this 137 IP. Both of those are coming in over a VPN connection to that. This was a point-to-site demo I did a couple years ago, and I mapped it out. And then in the cloud, we have this cloud domain controller and this SQL in cloud. The other complication we have with an availability group is we talked about that listener feature. And since Azure doesn't really support a second IP address or a floating IP address, the way you have to create this is an endpoint in Azure, and it's a different set of services. So it's a little bit harder to create your listener. It's not quite as simple as it used to be. If you have that add Azure Replica feature and you can use it, do it, because it will create the listener for you. And then just kind of a hybrid, high-level overview of the hybrid environment. Here we have our one on-prem SQL instance and our secondary. And this is almost always going to be asynchronous. Now, additionally, we can have multiple copies in Azure. So we could have a 3-member availability group with one of our instances in Azure, Northern Europe, and then maybe one of our instances in Azure US East. So we can really span multiple environments. Here are some resources I've listed, and these are kind of the links to help set everything up. Configuring point-to-site VPN, this is good if you want to play with this at home. Always on availability groups and hybrid IT that take you through the whole setup. Listener configuration for always on. HA and DR are using Windows Azure virtual machines. And this slide's from late last year, because at some point, Microsoft likes to change their marketing ideas a lot. At some point last year, we changed from Windows Azure to Microsoft Azure. And I suspect at some point they're going to change to Microsoft Cloud, because that's what they're using in all their public-facing marketing. And then finally, this is the link to the white paper I read on this with Stacia for using Power BI in a hybrid environment. And of course, the Power BI and the Office 365 hybrid stuff is pretty different than the Azure stuff, because we couldn't just have one mechanism for doing things. That would be way too easy, and we wouldn't have jobs. So in summary, Azure VMs and storage, we have pretty much all the same HA and DR options we have on site. The only one we really don't have is failover cluster instances. You can do failover cluster instances in the cloud, but you have to use a third-party storage replication software. I'm not going to mention any sponsors, but there's a sponsor I do work for, and unfortunately they're not sponsoring the event. That's why I won't name them, but I do some work for them, and they sponsor a lot of SQL Saturdays that has a product that does disk-based replication, and it's supported in Azure for regular clustering. If you want to test at home, point-to-site VPN is a great question. Yes, okay. The question was, who's the company? Sios? Oh, they are. Okay. Oh, okay. Yeah. Okay. I didn't know they were sponsoring, because usually they tell me when I'm speaking at an event they're sponsoring. Yeah. So Sios makes a disk replication software. Point-of-site VPN allows for testing from your home machine. You can do all. I've built all these scenarios in the last week in my home lab, so it's definitely doable. You want to use ExpressRoute if you're doing this in any sort of real production environment. The latency isn't too terrible with point-to-point or point-to-site, but some of the latency numbers I've seen with ExpressRoute are as low as 5 milliseconds, so that's really pretty good. And this is a really great model for smaller shops that have critical systems that they're trying to protect. One of the things I like to say is you can do DR really cheap. So if you're say log shipping and you just have a VPN appliance and you're log shipping to one SQL VM, you can even have that machine be very small. So you could have it be maybe the 2 processor 8 gig VM, and just while you're protecting, in the event that you actually have a failure, then you resize it, you take a minute of downtime to reboot it, and you can have a really big GSeries VM that will protect you. So it can be a really cheap way to do disaster recovery. So that's it. Does anyone have any questions? Thank you, everyone.